Welcome, agents, to this explainer. Your mission, should you choose to accept it, is to extract maximum marks from a hostile computer science exam paper in record time. Think of your upcoming Cambridge exam, whether you're tackling syllabus 0417, 0478, 2210, or 9618, as a highly secured, heavily fortified vault. You've got a very strict time limit to get in, secure those marks, and get out without tripping any alarms. Today, we're focusing on one of the most fundamental, yet incredibly frequently mismanaged, areas of this vault, the binary and Denary number systems. Now, you might be sitting there thinking, I know this topic inside out. It's just ones and zeros. But here's the reality check. Knowing the raw facts and knowing exactly how to extract the maximum marks from an examiner are two completely different skill sets. You've got the tools, now we need to talk strategy. Let's get to work. Okay. Let's dive right into this and ask ourselves a really critical question. Why is it that simply memorizing facts about binary and Denary isn't enough to survive the exam room? Well, the source material reveals a huge insight here, and it's a trap so many students fall into. A lot of avoidable, really frustrating mark losses happen because candidates recognize a familiar buzzword, like binary, and then they just get overly excited. They end up answering a completely different question from the one that was actually printed on the paper. Imagine you see a question about data representation, your eyes lock onto the word binary, and your brain just immediately dumps everything it has ever learned about ones and zeros onto the page. But here's the thing. Isolated definitions and random facts do not score top marks. A genuinely strong, top-tier answer starts by identifying the exact digital problem the question is asking about, and then linking that specific concept directly to the style of explanation the examiner is actually demanding.
To really see this in action, take a look at our two fallen agents here, Alex and Sam. Let's start with Alex's approach. The exam asked why a system uses hexadecimal instead of binary. Alex wrote, "Binary is base 2, using ones and zeros. Computers only understand binary switches." Now, is that statement factually true? Absolutely. Did it answer the question of why hex is used instead? No, it didn't. 0 marks. It's just a raw data dump without any analysis. Sam, on the other hand, went the other way. Sam rushed. The prompt asked to explain a process, but Sam merely described it, simply stating that binary is used for MAC addresses, completely skipping the how or the why. Both of these agents failed their extraction mission because they totally ignored the specific operational parameters of the question. They had the knowledge, but their execution let them down.
So, to avoid their fate, we have to first decode the most important part of the prompt, the command words. These words dictate the specific tactical demand of your exam. Examiners honestly aren't trying to trick you. They're actually giving you the exact blueprint for your answer right there in the command word. Think of it like a decryption key. If the prompt says state, you just drop a quick, precise, single fact and move on. If it says describe, you tell them what the device or process actually is. But, and this is crucial, if that word is explain, you are officially entering high-value territory. You must tell them exactly how it works and exactly why it matters. If you just jump into an explanation without clearly naming the concept first, or if you only give a basic description when they explicitly asked you to explain, your answer is going to come off sounding confused or shallow, and you'll leave marks on the table. Now, this brings us to what I call our tactical sequence for structuring those top-tier computer science answers, the PEL framework. When you are asked to explain a binary application, you absolutely cannot just write a giant rambling paragraph of random thoughts. You need structure. First, you make a clear point. Hexadecimal is used to represent MAC addresses. Boom, clear and direct. Second, you provide evidence or expansion. It compresses long binary strings into fewer characters. Third, you deliver the explanation. This makes it significantly easier for human network administrators to read and type. And finally, this is the secret sauce, you link it back to the real world or the core problem, thereby reducing the chance of critical data entry errors during network configuration. That structured, disciplined approach right there, that is exactly how you extract every single mark.
Let's test your field extraction skills right now with a quick interactive challenge. We need to spot the answer that actually utilizes that PEL framework we just talked about. Imagine the question asks why error checking is used in binary data transmission. I want you to mentally evaluate option A and option B. I'll give you a second. Look for the distinct point, evidence, explanation, and link. Okay, let's break it down. Option A just essentially lists methods, right? It says parity checks and checksums are used to find errors. It's true, but it's shallow. Now look at option B. It starts with a strong point about the risk of data corruption. It explains exactly how a parity bit works. It details the mechanism of checking that bit at the receiver's end, and then it links it all perfectly back to the necessity of retransmission if those bits don't match. If you spotted that option B was the ultimate extraction, your skills are definitely getting sharper.
Before we continue to our next clearance level, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So, moving forward, a really crucial point is mastering what we call the 3 layers of learning. This is all about moving your brain from simple everyday language up to precise technical vocabulary, and finally culminating in a high-scoring exam explanation. The source material notes that students very frequently think they totally know a topic until they actually try to express it in that critical 3rd layer. Layer 1 is just everyday language, like saying, computers use ones and zeros because they run on electricity. Right? That's great for basic understanding, but it's terrible for passing exams. Layer 2 introduces the technical vocabulary. Computers use binary, a base 2 system, utilizing logic gates. Much better. But Layer 3, the exam explanation, is where the maximum marks live. This is where you integrate that vocabulary into a highly structured, time-pressured response that directly answers a highly specific scenario.
And speaking of exam explanations, there is a very strict, heavily guarded boundary between a safe but ultimately shallow description and a full mark explanation of how a binary process actually functions. A super useful discipline for tackling binary systems is to rigidly separate these 2 concepts in your mind. Let's say the exam topic is an ADC, an analog to digital converter. A description just tells the examiner that an ADC is a hardware device that changes physical sound waves into digital binary data. Great, you've successfully described what it is. But an explanation goes deep. It details how the sound wave is sampled at regular intervals, how the amplitude is measured at each sample, and exactly how that measurement is converted into a binary sequence so the processor can actually store it. Examiners almost always expect both the what and the how.
Now, here is a golden rule. Context is king. Generic, copy-pasted textbook responses will get you caught every single time. You must always adapt your answer to the specific environment provided in the prompt. Is it a retail store? Is it a secure corporate network? Is it a school? Strong exam performance relies heavily on specificity. If a question specifically asks how binary data is read at a supermarket checkout, please do not write a generic, memorized answer about optical CD storage. You have to stay strictly inside that retail context. You need to talk about the laser scanning the barcode, the reflection of light bouncing off the white spaces, the absorption by the black bars, and how all of that translates into a binary signal of ones and zeros to instantly retrieve pricing data from the store's back-end database. Real-world transfer is what converts mere memory into actual usefulness.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's move deeper into our strategy with the technical sequence. This builds a highly disciplined path for classifying concepts and ordering your operations logically. When you face a really complex, intimidating question on binary processes, do not panic and absolutely do not start writing facts in a random order. You need to follow this extraction protocol. 1. Identify the demand. What exactly is that command word asking you to do? 2. Classify the concept. Is this a hardware selection issue? Is it a data handling process? Or is it a security judgment? 3. Explain the sequence step by step. In computer science, clarity of sequence matters immensely. Don't jump forwards and backwards in time. Be chronological. 4. Connect it back to the context. This 4-step structure is your absolute safety net in the exam room.
All right, agents, it is time for our first interactive workshop challenge. You have exactly 60 seconds on the clock to extract the core trend from a complex data source. Imagine you are staring at a really dense data table showing binary transmission times across different network protocols in a corporate office scenario. Protocol A transmits faster, but Protocol B has less packet loss. What is the examiner actually testing here? They aren't just testing if you can read numbers on a chart. They are testing your ability to evaluate trade-offs. You need to diagnose the type of thinking required. You look at the data, you find the anomaly or the clear advantage, and you frame it squarely within the context of that corporate office's need for security over sheer speed. So the core trend to extract is that while Protocol A moved binary faster, Protocol B's significantly lower packet loss rate makes it the far superior choice for a secure office environment.
Let's keep the momentum going. For Challenge 2, I want you to mentally scan this flawed paragraph and find the exact sentence that is bleeding marks due to common, totally avoidable exam traps. The paragraph reads, "The automated factory uses sensors to gather information. This is sent to the microprocessor. It is better because it is faster. The system uses binary." Okay, where's the flaw? Well, actually, there's a whole bunch of them. First off, sensors gather data, not information. That is a massive terminology confusion right there. Second, saying it is better because it is faster is stating an advantage without giving a reason. Why is it faster? It's faster because microprocessors process binary data electrically at speeds a human simply cannot match. You must always justify your claims.
You see, examiners absolutely love to set traps using similar-sounding terms. It's how they separate the top grades from the average ones. You have to clearly understand the strict boundaries between concepts. Take memory and storage, for example. The theoretical foundations of computer science depend on these distinctions. If a question asks about secondary storage for a binary application, and you start enthusiastically writing about RAM, your mission has instantly failed. RAM is memory, it is volatile. A hard drive is storage, it is non-volatile. It's the same thing with understanding the difference between a compiler and an interpreter, or data versus information. Your reasoning becomes so much stronger, and honestly, your answers become much faster to write once you map out these boundaries clearly in your mind.
Now for the ultimate test, a 30-second speed writing challenge to draft one perfect, context-driven Peel paragraph on binary systems. The scenario is this: justify the use of solid-state drives over magnetic hard drives in a portable laptop. Go. All right, let's break it down fast. Think about your point. SSDs are far better for portability. Think about your evidence. They have absolutely no moving parts. Think about your explanation. Because they use NAND flash memory to store binary data electrically rather than magnetically on fragile spinning platters, they are incredibly robust against physical shocks. And finally, your link back to context. Therefore, if the portable laptop is accidentally dropped while traveling, the user's binary data remains totally safe. That right there, that is a maximum mark extraction. Perfect execution. Before you wrap up any answer and extract yourself from the exam question, always run your response through this 4-question final system checklist. It's the best way to guarantee top marks. This is a highly practical self-check. Ask yourself, what is it? Have I clearly named the specific binary concept? How does it work? Have I explained the underlying mechanism logically and in order? Where is it used? Have I tied my answer specifically to the real-world context of the prompt, like that factory or supermarket? And finally, why is it better or worse than an alternative in that exact situation? If you can confidently answer those 4 prompts based purely on what you've written on the page, your answer is ready for submission. If not, go back and reinforce it.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Knowing the theory of binary and Denary is just step 1. Rehearsing worked explanations, diagramming truth tables, mapping out system sequences, that's step 2. But that final step, the one that actually bridges those grade boundaries, focuses entirely on your adaptability, changing the context, navigating tricky terms, and forcing yourself to justify choices under pressure. That analytical structure is so powerful because you'll use it across every single chapter of the Cambridge syllabus. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep refining your extraction strategies, agents, and stay hyper-focused on those command words. Before you step into that exam room, ask yourself, are you just memorizing the vault's blueprints, or are you actually prepared to break in and take what's yours? Good luck out there. We'll see you on the next mission.